Hello. First, I have the hat from an organizer. After this talk, we'll be taking the group picture just outside. So if you don't want your picture taken, then run, I guess. Right. So with that being said, I'll take off my presenters, like my volunteer hat, and go into presentation mode. First of all, again, let's thank our lovely sponsors, and with a round of applause. This applause is mainly for me because I'm a tad sleepy. Not only for them. So, you've come here to learn about going from object-oriented programming to functional programming. My name is Joaqui Azcarate. I work at Appium Hub, and you can find me either at florius.com.ar or just walking about. All right. Oh, them. So I'll be joined by Forza, and they'll be accompanying me in these slides. So let me introduce you to them. They don't work at Appium Hub. They are just a figment of our imagination. So Forza is the super awesome, self-aware, slightly acid slides accompaniment. And that is because I myself have sat in way too many talks where the presenter here talks about all the benefits and everything that can be good about something, but never discusses any of the costs and never answers any of the tricky questions about the topic that they're discussing. So Forza here will provide with some of the counterpoints to meme. So let's veer for the norm and have them provide the counterpoint. All right, that being said, forewarning, I am not here to tell you that functional programming is better. Well, maybe I am. The actual title name should have been something like coming from procedural, we moved into imperative, and then we have to choose between object-oriented and functional programming. The thing is that was like have the real state of a treat. So this is what we get. So with that being said, let's hop aboard the train and go out from object-oriented land into wonderful, wonderful nirvana of functional programming. Choo-choo. So OOP, what is it? This legend we have to thank Alan Kay, co-founder of the Smalltalk programming language. He worked along with many others in Xerox PARC, and he coined the term object-oriented programming. He was not the first to call objects as an object. That was a bit before his time. And he famously said that he was very, very sorry that he coined the term object for object-oriented programming because it was the lesser of the two ideas. The better idea was messaging. Right? The how something behaves is way more important. Simula67 was the first one who actually coined the term object in here, I think. Yeah, new object belonging to a class. And whenever I see the Simula paper, I get baffled at how little we change from syntax from one side to another, right? This is Kotlin. It's been out for like a month, I think. And like you can read Simula and think, oh, this is just like any other piece of Java code. Well, it's true. It's true that functional programming might have come a bit earlier, but John McCarthy, the creator of Lisp, famously said that he did not understand lambda calculus. So it's wrong to think that lambda calculus has anything to do with functional programming. I guess the syntax hasn't changed, but if it ain't broke, don't fix it, right? So, object-oriented programming. We sort of have a vague idea of what it means, having objects, having messages. There is, having objects, having messages. But let's focus on what a paradigm is, right? What objects and functional have in common, the paradigm part. So, a paradigm is a way of a lens on which we see reality. Reality is way too messy. It has quarks, it has Higgs bosons, or maybe not. I have no idea what that means. But the idea is we need a way to learn about the thing that we are trying to model. Object-oriented programming means everything is an object and has messages. But there's this third part that nobody talks about. Dan Ingalls, again, co-author of Smalltalk, worked with Xerox PARC, worked with Alan Kay, sort of coined the term. He said that we also need a formalization of a protocol, and I'll get to what a protocol is. And this was 2 years after the first Smalltalk paper was published. So the idea of a protocol, the way that he describes the protocol is, we'll figure a syntax from now until like 3 or 4 years. It's been 50 years, we haven't come up with a solution. So his idea of protocols is what we basically understand as polymorphism. Say you have a car and you have a currency and you can ask them their cost, right? And you sort of expect, okay, the car might ask its parts, its costs, and maybe a currency can either go to a stock exchange and give you the cost, or maybe what's the cost of the paper, but you don't expect them to return like red, right? This is the idea of protocols. This is not types as we sort of envision them. It's a bit more abstract. But he mentions that we also need something like that. So, oh, right. I have talked about three people, right? Two of them which worked at Smalltalks, and they're both male. But this is not that doesn't mean that there were no other females in the team. This is Adele Goldberg, genius mathematician and programmer, and she worked alongside with both Alan Kay and Dan Ingalls on the whole of the rest of the team and Smalltalk. Like, she even wrote the book, for Christ's sake. So, object-oriented programming, sort of have a big idea of what it is, right? But you're here just for the functional part, I guess. And I remind you that there is a general lack of my part for design patterns, right? We all know Gang of 4. Maybe you've read the book. Maybe you haven't. If you haven't, don't. Design patterns that sort of guide along you on object-oriented. And I have not talked about any of these things, but we got an idea of what object-oriented programming means. In the same vein, I will not be discussing any Kleisli arrows or semigroups or visitors or monads. Visitors is object-oriented. And I know that I say the word monads, and I'm not going to say anything more than monads before that slide. So these sort of things emerged on how we thought about functional programming and object-oriented programming. They were not part of what makes object-oriented or functional programming the thing. They're just things that happen when you sort of look at the life with an object-oriented or a functional programming lens. So now we'll just talk about function. I know, it's somewhat contrived example of saying that everything is a function, but it is in some level true. So what do we mean about functional programming, right? What is the lens on which we see the functional programming world? Objects were objects and methods, and functional is functions. I know, it's not terribly helpful to think about, oh, functions or inputs and outputs. So let's try and visualize what functional programming actually means, right? And I'm going to pose that functional programming dedicates more of its energy into describing what something is, right, rather than how to do it. I guess so, yeah. I guess that nowadays object-oriented programming also has this idea of filter and map. Yeah, but they stole that, right? Functional programming is better, like it's more descriptive. Oh. Is it? So I guess that what something is and how it behaves is more declarative in object-oriented land, because you have something that it behaves, you get methods, whereas in functional programming, you sort of have to describe how something behaves. Okay. So in that sense, let's have an idea of we have a program that is programmed in functional programming, right? And then you can write the same thing in object-oriented, right? So if there's a continuum on what code you can write, like what lines of code you can put into one or the other program, then there must exist a boundary, right? Must exist a functional programming language that you change the slightest and it jumps over to the object-oriented land, or the reverse, right? You have an object-oriented programming which you change one semicolon and now it's functional. And I don't know about you, but that idea feels wrong, right? Like you cannot have something that is functional programmed and change it just a bit for it to be functional. And this is sort of the Sortier's paradox, or if you are more inclined, the Bolzano theorem. That means there is no boundary. Having an idea of there is a boundary between functional programming and object-oriented programming is false. It's demonstrably false. If it were, there must exist a boundary. There is no such boundary. So this talk has no meaning at all, right? Like I started saying that we are gonna go from object-oriented to functional programming, but we just demonstrated that that could not be the case. So this is me being a boy in front of an audience, trying to convince them that tomorrow, Monday, you go back to your work and you rewrite everything in Haskell. I know. So this idea, right? We proved something based on, like, the premises are false because we reached something that is absurd. Like this is the proof by contradiction, right? There is not such a thing that it is unequivocally functional programmed or something that is unequivocally object-oriented programmed. And this is harder nowadays, where object-oriented languages and functional-oriented functional programming languages, like, they copy things that are good from other places. Like, you say Java, the object-oriented programming, has closures, something that is functional. Or you have Haskell that has type inheritance that is very object-oriented, right? So having an idea of something to be functional or to be object-oriented is demonstrably false. So I know, I'll stop with the philosophy, I promise. So we cannot move to object-oriented programming. There is no such a path to move from something one to another. But there is something of functional programming, right? We read a lot of blog posts about them. You've come here to hopefully get an idea of what functional programming means. And I very, very often have to describe functional programming as something that it isn't, right? You hear functional programming as a lack of mutation and a lack of loops and a lack of uncontrolled side effects. Okay, I'm gonna keep in the spirit and say that functional programming is not magic. Even, I'm gonna say it's not even sufficiently advanced. Again, functional programming has been here for a long time. Lambda calculus is literally 4 lines of ideas. That's it. That's the whole thing. So if you want to learn more about what a functional programming might incur, right? What it might be in an abstract way, there is this great talk by Ross Olson from 2018, and he spends 40 minutes trying to describe what functional programming is to him or how he understands it. But the one slide summary is, first of all, it is an arbitrary engineering decision, right? To remove things. Imagine that at some point we had gotos, right? Languages were capable of jumping around. And we said, let's not do that, right? Code, it's messier if we do that. Let's remove some of the potential things that we can do in order to make, in the hopes that the code that we write is easier to understand. Functional programming is in the same idea of we are arbitrarily choosing not to have side effects and have everything, every data part completely immutable. And this comes with an interesting set of ideas that come up with it. But as far as it tells, it is by no means magic. Like, you can have bad code. You can have code that performs slowly. You can have code that does not do what the customer intended for it to do. You can have redundant code. Like, being a functional program is not that there's one single solution to any one problem. Like, you can have 2 people that go out and try to solve the same thing, and they solve it in way different ways, and that's okay. Like, you're gonna have that in object-oriented. You're gonna have that in functional, and there's always out by one error. So at this point, you might be wondering, well, why am I here, right? There's coffee outside. Why am I here? And if nothing else, I'm gonna go on another fallacy and say the idea of multiple flies like something, and say that object-oriented has been in the decline, right? This is actual proof, if you can call that, of object-oriented being on the decline. Functional programming is very slightly going up, but not by a lot. But I do think that functional programming has its dawn to be had, except in France. I have no idea what France is doing, but France, keep doing that. And I know this talk has been a lot of me talking, a lot of me philosophizing, and there was not a lot of substance, right? So let's try to remedy that, and let me give you some of the tips and tricks that I've learned along the way. And there's this thing that Douglas Crockford famously, I'm gonna say, wrote JavaScript. He and some other people, and I ignore the monad part, but he says, and I very much agree, that if you have something that is sufficiently abstract and you understand it and you can use it, then you lose all ability to explain to other people. And I very much think that that is true. So I'm not going to try to explain what functional programming is to me, because I am very sure that I've lost that ability. But I can give you three pieces of enlightenment that I remember having had and saying, well, functional programming might be the alternative, might be a solution. So the first off, and Eric slightly talked about this in his talk yesterday about dependency injection, right? So prototypical Java application, Spring, if anyone knows, you have something that represents a repository and has a database and has a method to find something, and then you use that repository in order to access the database. At this point, I hope that I haven't lost anyone. So what does functional programming mean in this sort of way, right? Those were objects with methods and behavior. We don't have that in functional land. So the thing that it is used very often is this idea of having a function that returns a function that returns a thing, right? So if we just focus on the highlighted part, we have a function that, given a string, it returns you a book, right? And that part is the same. But the problem in the object-oriented part is, in order to do that, you need a database. And how do you achieve that in functional programming? Then you close over with another function that you provide a database. So this is no wonder why closure is called closure, because we do this a lot, right? The idea of, how do I have an internal state of a thing? Well, provided it does not mutate, then this is the approach. You enclose it with another function. So next thing that I always hear is that I want to mutate things. Like, why would somebody want to mutate things? I have no idea, way beyond me. And I always try to explain this idea of the paradox of the ship of Theseus. Ship of Theseus basically says, imagine that you have a ship made of planks of wood, and you take out one of the planks of wood and you replace that. Is that the ship of Theseus? What if you do that with all the planks of wood? Is that the ship of Theseus? What if you take all the planks of wood you removed from the original ship and you build a new ship? Is that the ship of Theseus? Like, what is even change? And the closure people have this idea, and it's very smart, that we need to think about state and identity as two separate things, right? Things don't actually change. The idea of it is a fool's errand to think that you get into the river, in the same river twice, right? The river is the idea, but it is not always the same. It does not change as we envision as having variables in our code base in object-oriented. So if I give you a book and I give you a book and I ask you which one can be mutated, you have no idea, right? Because a book is a book. A book is the thing. You can work with things and not having an idea that they have been mutated or not. I don't remember why I put this slide, but these are my cats. That's Melia, that's Erwin. Okay, yeah, I know. I am blatantly ignoring the part where you have one piece of code that needs to know about the changes of another piece of code. But I'd reckon that we all sort of agree that that is the go-to of our time. That is the thing that has been moving us away from object-oriented programming. We have something that changes, another part of the code needs to know, or rather more importantly, does not need to know that it has changed. So I'm not going to go over like what change, or I already went over what change means or what doesn't mean, but I'm not going to go over this notion that we need things to not collocatedly know when other things change, because again, that is the whole point that we're using functional programming, to not have to have this discussion. But you need to write code, right? At the end of the day, you cannot go to your client and say, I went to a talk that called about sheep of Theseus and said that change doesn't matter, right? So this is a prototypical example of having something that changes, right? So this, okay. So you have a repo and you have a book and you reduce the stock and you capitalize the title and these sort of things mutate. And the first thing that one does, if you need to know that things cannot mutate, is you make a copy. So you have this book that returns a book prime, and you use the book prime to return a book prime prime, and so on and so forth. This idea of having something that, given a book, mutates things, rather have a book that returns a book. If you do the second thing, you can go to your managers and say, I am doing fluent API design, because we can line up the dots and don't have to worry about the book prime, 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 prime. So yeah, go say that you want to rewrite your whole code base in Haskell, and then you're doing fluent design. Great ideas. Anyway, third piece of enlightenment, and I think that this has been, for me, the way of me to onboard people into functional programming is that at some point in their life, they sort of get that functional programming has its benefits, right? They understand that maybe things that are too algorithmic work best in functional programming, or something that they read in a paper of an optimization sort of translates better in functional programming than in object-oriented programming. So I'm going to propose that whenever you have this sort of idea that functional programming might be useful, but you have a whole code base of object-oriented programming and mutation and side effects, then establish a boundary. Get everything that you need from that point onwards that is not functional programming, right? That has side effects, that need other things, like the repo that we talked about, or any random number generator, or any clock, and establish a boundary. In that way, you can have the top example, right, is the way that you would usually write it, right? You have a use case and a database, and you do things with it. Then establish a boundary. Even create an object that's called boundary, where you can inject everything into it. And again, this sort of idea of dependency injection comes up here a lot. And imagine yourself that inside the boundary, you're only doing things without side effects, without mutation, without any of the ugly pieces of code that you can write. And in that boundary, you can write functional programming. You can write things that use functions and things that depend on functions and compose well and don't have side effects. And the way that you do it is you sort of auto-wire, if you want. You sort of build the pipework in this part of the boundary, outside the boundary, and then using the inside of the boundary to do your functional programming. And you might ask, well, lines of code-wise, I'm losing a lot, right? The first example has, 5, 6 lines of code, and the second example has way more. And I'm going to go out on a limb and say that the pipework is very marginally bigger, right? You need some pipework. Yes, that is true. But the benefits that you can reap from inside the boundary will overshadow the additional lines of code that you need to create this boundary. And if you imagine just 1 second, like, how would you test the first thing, right? You need a database. So let's get there. So if you need the first part, right, you need a database. You need a database to mock, to do your changes. And this is somewhat costly. You might have your Docker instance spool up a database. You can have a mock implementation of your database, or you can Mockito or any other of the myriad of mocking libraries to provide this. In functional programming world, there is I don't think that I have ever seen a mocking library. It has it is senseless to think about a mocking library. In the second part, you only need these 2 functions that do things that you can provide, because functions are like the bread and butter of functional programming, and that's about it. You don't need any of the mocking that you usually encounter in object-oriented land. And that, for me, is like the biggest winner on this, right? Having the ability to test things without having to worry about mocking, about wiring things, about spooling Spring onto Spring, being that Spring from Java or being that Spring from Ruby. If you ever worked with Ruby, I'm very sorry for you. So try to understand it as a boundary where in the outside, like in the outside of your boundary, you have all this logic and all this code that does the things that already work. But inside the boundary, you are in a happy functional programming land. And I'm gonna propose that if you can do that at any boundary, like we chose a boundary completely arbitrarily, you could do that one level outward. And you can grow your functional programming code base growing one level up, right? The use case that we saw, maybe it's used by another use case or another controller or another whatever, that you can push that boundary outside. And I know that this is not induction because I'm not proving that at some point this must be true for one. So just believe me. So at this point, you might be thinking, okay, it's just a matter of style, whether I do object-oriented programming and functional-oriented programming. And that is sort of true, but this sort of this segues into what I'm gonna try to explain this last point of the word. That is John Backus, famous John Backus, like BNF. That B is him. He won a Turing Award in 1977, right? 10 years after Simula, 10 years after object-oriented programming. And it is a great read. It is a bit too straightforward in what the things that he says, but they already knew at that point, 1970, right? Remind you, 1977, that there were things that were wrong on how we thought about we thought about programming. Object-oriented was not the norm there. There was very much imperative code running around. And I'm going to say that object-oriented programming, the way that we usually do it, is more akin to what imperative or Fortran, the guy made the Fortran compiler. So he knows about Fortran. And he saw that the code that was written in Fortran was very, very much not the future of our civilization. And yes, I know that I'm quoting a lot of people and asking you to believe that because these people said it, it must be true. And I don't have a solution for that. But I do think that we can all agree that at this point, the things that we are doing have grown way too complex for us to handle. That we have a lot of code base that is way too difficult to reason about. And maybe it's not about object-oriented programming. Maybe object-oriented programming won the Darwinian fight in the 90s, and we are doing object-oriented programming, and we are in this mess, not because of object-oriented programming, but because of the ways that we sort of developed. So to try to understand a bit of why that is the case, again, a great talk by Richard Feldman of how we got here. Like, why is Java, why is Ruby, why is Python, why is, I don't think that he calls out C#, but why is functional programming not the norm? It is very interesting talk. I highly recommend it. He's very entertaining to watch. And the one slide, the one slide abstract is right there. It is very complicated. Like, it's not because they were just better things. It was not because somebody proved that object-oriented was in fact better or any of that. It's just a matter of merchandising. It's a matter of lobby. It's a matter of killer applications or killer libraries. Very interesting talk. Highly recommend. So we are reaching the end part of the talk, and I hope that at this point, if you loved object-oriented programming and you've heard me tell the tales of functional and you didn't like them, then at least I hope that I pushed you more inside object-oriented programming and that you find a new love and new respect for object-oriented programming. If you already loved functional programming and you didn't need somebody to tell you that it might be the new thing, then great. If you were in the boundary, then at least I hope that I provided both parts, or me and Forza provided both parts of an argument of what functional or what object-oriented might mean. And I will leave you with this last one quote, that is, that when you have done object-oriented programming for your whole life, but you still have pain points, then whatever alternative, however weird it may sound, like not having mutations, not having side effects, must be the truth. And of course, I said this. So that was it. I was Joaqui Azcarate. Thank you very much. Forza also. The links the talks that we discussed and the links are at fp.flores.com.ar, or I'm gonna leave I can leave this talk here. And I'm gonna thank all of these lovely people who I blatantly stole their images. And yeah, that was it. Thank you very much. I'm gonna leave this slide here because I always forget to repeat the question, but I dread whenever there's no questions. So I'll have a question for you. So whoever wants it, raise your hand and ask this one question. If anyone has any questions or doubts, I'll be happy to answer them here or be outside whenever you want.